Well, thanks everyone for being here today. I know it's we're learning a lot. It's great to see kind of the vision of the future from DDN just there. So anyway, I was asked today to talk about the Intel Omnipath architecture and how it operates with Lustre, what are its implications, and kind of go through some of the details. I am a Lustre Solution Architect in the Intel High Performance Data Division, so I probably have met some of you around in the ecosystem. This is an Intel presentation. We have a legal slide. I would like to give just a quick LNet introduction for those of you who know Lustre very well or don't know Lustre very well. Just settle on what that actually means. I'd like to talk about Omnipath architecture. I'm not going to go into a bunch of feeds and speeds and a bunch of detail on that. There's a lot of other people at Intel well more qualified to deliver that speak. I'll talk about LNet and Intel Omnipath. What does it actually mean to the file system? Where is it utilized? How does it behave? And I'll talk about how to integrate LNet Omnipath into existing architectures, right? Everything's not greenfield. It's not all going to be OPA anytime soon. So, LNet introduction. This is a core architecture for picture Lustre. This one has a lot of colors. It looks a lot like every core architecture picture you've ever seen. Lustre is a client-server architecture. Between the clients and the servers, there's something we call LNet. It's generally a high-performance, hopefully dedicated network that we get to utilize. Lustre itself is responsible for moving the data from the storage to the clients. If you want to have a file system that does 200 gigabytes a second, guess what? Your network is extremely important in these conversations. LNet is kind of the third, sometimes less spoken of component of your file system between the clients and the servers, but it handles every single I/O and is responsible for everything, right? That's LNet. LNet is itself designed, is actually a separate project from Lustre. It's in the Lustre Git tree, but it's not in the Lustre source code. It is its own thing with its own abilities. You can think of LNet as a logical mapping layer for existing drivers, and we'll talk about that a little bit more. LNet is an extremely flexible layer that's been designed to meet the challenges of HPC. We can simultaneously exist on more different fabrics at any given time than probably any other file system in the world. We can simultaneously operate on Omnipath, InfiniBand, Ethernet, Cray, Interconnect, and a bunch of other HPC interconnects that have been out there. As Lustre is hardware agnostic, we are hardware agnostic in the fabric. Lustre again is, LNet again is separate from the Lustre file system. I know it feels like the same thing, but it's slightly different. And it is implemented in the kernel level, so this is all done in kernel. Networks themselves are given unique names. We roughly take interfaces that are existingly configured, Ethernet or InfiniBand, and we give them unique names like O2IB, that means InfiniBand in Lustre, or TCP, that means Ethernet in Lustre. And we qualify what a network is, and this is just a logical mapping on top of the physical network itself. We can support multiple interfaces at the same time, so you can simultaneously serve Lustre from InfiniBand and Ethernet, although it's not generally recommended due to performance concerns. You can mix and match and do a lot of different things in this L networking layer. The basic I/O path from the application writes something in the POSIX layer, it then gets converted into a network RPC, that gets handled to LNet. Then there's something called the LND, you can think of that as an LNet networking driver that hands that off to the individual networking driver under the hood. All this layering gives us a lot of flexibility for LNet. So that's LNet's job, right? To abstract the physical network into something that Lustre can use. And Lustre itself is abstracted from the networking types, which gives us a lot of flexibility. Okay. Intel Omnipath architecture, right? We've been talking about this for a while. It's a new 100 GB fabric, and it's not just 100 GB. There's also an 8x adapter that's out there that runs at half speed. There's very interesting things about the density and the types of cables you can use and all sorts of things. It is both fabric, it is both silicone and technology together with software that delivers the solution, right? OPA, we do see strong adoption across the industry. There's a wide variety of OPA solutions out there from multiple vendors. It is a real system. So what is Omnipath architecture mean for LNet, right? How do we merge this fabric in, right? Omnipath isn't InfiniBand. It seems like it's InfiniBand, but it's not quite InfiniBand. You can't plug an Omnipath cable into an IB switch, for example. It doesn't work at that level. So when we think of well, what does it mean? It means that we have to have a relatively recent Linux distribution to support it. That's because of a driver issue for Omnipath architecture itself. Right now, Omnipath is well supported in the Linux 7, Red Hat Linux 7 space and the SUSE Server 12 space. That's where the OPA drivers list. So that is also where Lustre exists. You may have seen a move this year as Lustre has moved a little bit away from RHEL 6. We as Intel actually don't support in our current deployments. We don't tell new people to go out and deploy on RHEL 6. We actually tell them to go RHEL 7. And Omnipath is part of that conversation that we have with ourselves with modern hardware support. Lustre itself needs to be at least Lustre version 2.7. That's our Intel Enterprise Edition 3 base, which becomes exascalar current or a wide variety of other things. There's specific implementation deals in the Lustre LNet layer that enables OPA to work, and that requires a reasonably modern Lustre. Intel Fabric Suite is effectively the software component from Intel that the Omnipath team delivers, and this delivers driver updates for the in-kernel base OFED. So if you think about how OFED works, OFED is the software component of the base OS that allows you to translate your calls into the native Fabric speak. And the Intel Fabric Suite has taken the proposition of working with the in-kernel OFED that exists there today and only upgrading or impacting pieces of the framework that it needs for its own operation. This means that OPA can interact with other things that use in-kernel OFED. We don't necessarily remove the functionality to use the MLX driver, for example, when you deploy IFS. We'll talk about that a little more. Intel Omnipath Architecture Gen 1, the products that we have today, and there's follow-on gens and roadmaps for all of that, right? Supports RDMA verbs in OFED, and if you know much about Lustre, you know that Lustre uses RDMA verbs to work. So essentially, LNet's just another InfiniBand driver from our point of view. There is only basically tuning in the Lustre LND. There are some module options that are recommended to deploy, and if you driving tuner requirements to utilize to properly configure your system for OPA. The LND settings, the actual specific LNet settings that you want to use, there's actually an automated script that runs when you install Lustre that pre-deploys these for you. And they're well documented in our architecture out there. There's a lot of architecture. There's a lot of white papers and user guides about how to utilize this technology with Lustre, right? So as I mentioned earlier, right, there is a challenge with Omnipath architecture in that it isn't InfiniBand. It doesn't conform to the InfiniBand specs. You plug the cable in and nothing happens. What do we do? How do we move forward with that? This isn't the first time Lustre has encountered two different fabrics that won't work together. In fact, we're extremely hardware agnostic, and LNet itself has a very graceful solution for it within the LNet router space itself. You can, and this isn't just about InfiniBand and Omnipath. This could be InfiniBand and Cray or Ethernet or Omnipath and all kinds of different ways to mix and match LNet routers in your environment. You can take Lustre Omnipath components, install LNet routers, and bridge that to InfiniBand, and really bridge that to anywhere else you want to bridge it to. LNet routers are simply Lustre software with standard hardware. There's no special hardware required. You can use off-the-shelf. You can have, certain OEMs have certain solutions for this. There is tuning and configuration that happens to your cluster when you install it, essentially dictating routes. LNet routers are used generally in a cluster deployment, such that you don't normally have a Lustre router, but you have many Lustre routers. And sites have used LNet routers in a lot of different use cases, moving hundreds of gigabytes a second of traffic around their data center to connect different fabrics together over different times. So what is supported today when we think about these LNet router overviews with Omnipath to InfiniBand? I think that's the most relevant conversation we have, right? It's definitely easily and non-trivial and actually quite trivially supported to run Intel OPA and Ethernet together in a router bridge. It's very possible to use Intel Omnipath and FDR and EDR. Red Hat 7.2 is required because of the in-kernel support statements from Mellanox around the MLX5 and FDR and EDR support. And there are specific changes within Lustre to allow two separate InfiniBand interfaces to run at the single time. So again, with Red Hat 7.2 and a Lustre 2.7 Plus, kind of a current Lustre software stack, you can build and deploy these routers. We do have a guide, Intel Enterprise Edition for Lustre software configuration for LNet routers that goes into technical detail. I didn't want to go through the minutia of what the command line looks like, people. Just a quick update. That's out there so you can read. So just a quick wrap up. Again, this is just a short conversation about this, just to give you a better idea, right? Intel Lustre OPA is in production today. I think Pittsburgh Supercomputer is a relatively public site. They've been running for a while. Last I heard, they run around 900 clients in their production system today. LNet routers provide flexible deployment options for deploying different fabric types in Lustre, and specifically for this OPA to InfiniBand type conversations. There's guides you can read about that are produced and are out there. If you want to learn more, www.intel.com/Lustre. We have a lot of stuff out there, from some of this information we talked about to free online user training to a whole host of white papers and things. So I know that was a little fast and quick, but anyone have any questions they'd like to ask? OPA, Lustre, anything?
Not really Lustre, but you have the same problem with QBFS. So what happens if customers QBFS and the Lustre has Omnipath?
Yeah, no, I think that's a good question. And roughly what I've heard, you have to convert the InfiniBand to IP and use IP routers to do that. So you have to switch it out of the RDMA protocol. So Lustre has an elegant solution to this problem as far as we're concerned, and it's a unique advantage of Lustre with this technology. Others aren't so benefited. Yes?
When you say Red Hat, do you include CentOS in that?
Yes, I do. Yeah, we treat Red Hat and CentOS as the same thing within our world. Most of our Lustre users, because they're HPC, run CentOS, but it gets complicated to say Red Hat on CentOS every single statement. So, yeah. All right. Any other questions? Oh, yes.
Is there a version limit for? Thank you. Is there a version limit for OFED drivers?
Yeah. So for OFED drivers, so how IFS works today is it relies on the in-kernel OFED to be present. So we follow what Red Hat just builds and ships and deploys themselves, and then we update that within itself. So with Omnipath architecture, you're not mixing and matching OFED versions a lot. You're using the in-place kernel plus any potential updates from Intel in the IFS driver. And it's a minimal touch. I believe Red Hat 7.3, it's been confirmed that that will have an OPA driver present that doesn't even need the Intel Fabric Suite to operate and manage. But we're a light touch on top of the existing OFED. If you want to go off and run different OFED stacks, it may well be possible, but it's not inside of the highly known box. So, yeah, you can't put. Just to be perfectly clear, you can't put MoFed and OPA together in any sense of form or fashion. That just doesn't work and doesn't go anywhere. So you have to be really careful with this.
So this isn't specifically Lustre related, but does Intel have an answer to the notion of GPU Direct with Omnipath, i.e. will Omnipath support things like GPU Direct, which EDR does now?
I don't think we have GPU Direct. We have enabled the Omnipath directly in our Knights Landing platform. So I think we go about the problem of GPUs and enabling that in a different way. I have not heard. I'm from the Lustre team, and I'm not deeply engaged to know if they're doing that or not, but I wouldn't be surprised if we're not. So, any other questions? All right. Well, thank you. I'll hand it over to the next.